All right, thank you. Welcome, everyone. My name is Ben Silverman. I'm from Mirantis. I'm a senior system architect with Mirantis. Been doing OpenStack for quite a while now, and have had a lot of experience with production clouds being stood up and production workloads. Prior to Mirantis, I set up the first American Express internal cloud. We had about 120 nodes of Icehouse that hosted about 5,000 instances. I was head of architecture, head of engineering, and head of operations because there was no such thing at the time. So I felt the pain that a lot of you feel, when doing OpenStack. So I'm kind of bringing this information to you, so maybe we can skip some of this and get right to the good stuff. So capacity planning, what is it? Here's Techpedia's definition. Obviously here I want you to pay attention to it's capacity planning is planned over a specific period of time, and it forecasts future requirements. That's it. Everything else around it is fluff. What are we capacity planning for? Compute, storage, network. People could say people. That would be another one, but again, that's more HR planning, not capacity planning. I'm sure most of you already get this. Okay, we want to make sure that everybody gets this drilled into their head. Cloud does not equal virtualization. OpenStack does not equal VMware. OpenStack does not equal bare metal. So, cloud, typically ephemeral workloads, horizontal scaling, predetermined capacity, meaning you order an M1 small, you order a certain flavor, it's predefined, that's what you get. You don't grow it, you don't shrink it, there's no vertical scaling to it. And the short life cycles, maybe more speaking towards the DevOps side, CI/CD cloud, where comes up, is tested, used, and folded. Could be in production too. Again, we have to assume failure, so short life cycle possibly over there is in production as well. Virtualization platform, pretty much the opposite. Persistent workloads, you set them up, you let them go. When they die, you have to reclaim the resources, do all that type of decommissioning, vertical scaling. I need more power. OpenStack says, go horizontally, create more instances. VMware, they say, okay, I'll turn the CPUs up for you. I'll turn the memory up for you. OpenStack, no such real concept if it's done right. Again, dynamic capacity, I'll add more disk for you, I'll add more memory. And then longer life cycle. These things are persistent, they're expected to stay up for an extended amount of time. Common myths. When I talk to people about OpenStack or iCloud or EC2 or you name it, Google Cloud, it has unlimited resources. The cloud is infinite. I can get as much storage as I want. No, that's not even close to true. Elastic has infinite scale. Again, not true. It can scale to massive scale, but everything in the cloud every virtualization is tied back to a physical piece of hardware. There is no magic, there's no unicorn tears, there's no kitty glitter. It is all tied back to a piece of physical resource. So, we have a capacity problem in our current environment. Elasticity solves the problem, right? Put a whole bunch of resources. We'll never have a capacity problem again because it's elastic, right? No. Another myth. Elasticity helps, but does not solve the problem and actually brings on some more challenges. That's why this speech exists, this presentation exists, because we're going to talk about how to do capacity planning in an elastic cloud. And if I'm moving too fast, I'm sorry, I only have 12 minutes. I'm going to try to give as much value to you as I can. It's not the responsibility of the cloud provider to provide risk management through capacity planning. Yeah, it is. It is. As a service provider, it is your responsibility to provide capacity for your cloud to your end users. It codifies that relationship. Could you imagine if AWS said, well, you ordered too much. That's why we ran out of capacity. You wanted too much, you wanted 500 terabytes of disk. We only had 400 available. Your fault. No. It's the service provider. So, how are we going to do this? How in general are we going to do capacity planning? Well, obviously we have to define our workloads and our workload requirements. Then we bring them to the cloud. Some people have said, do use DevStack. set up a small dev stack, put your workloads on there, test them, see how they react. I say no. I say get a production-like environment as much as you can, and then put it on there. Your POC should look somewhat like you're planning with your production. So if you're going to use Ceph storage, if you're going to use Scale IO, or you decide to go with a huge VMAX appliance or SolidFire in production, please don't use local disk in your workload testing. Please make it look somewhat like your POC, your production. Proper flavor definitions, CPU, memory, and storage. I'm going to be giving a talk in Barcelona on this, a full-length talk, where we will go into how to define flavors correctly and how to make them most efficient for capacity planning. But the long and short of it is, these flavors, they have to be defined properly, and we'll go into that in a little bit. Monitoring metrics and churn calculations, you cannot monitor, you cannot measure what you cannot get metrics from. So that's very important that you have data. And then developing triggers for expansion that meet financial and demand limits. If you don't set a trigger, you never know when it is that you need to expand storage, compute, networking. Workload testing, like I said, test in the most realistic production environment you can. Compare results against your other baselines. If you have a VMware environment, do not take your VMware VC ops data and say, oh, that's what I need to run in OpenStack. Different hypervisor, different environment, may be better, may be worse. Check it in your existing environment, your existing OpenStack environment. Use incremental adjustments in your flavors to find the sweet spot. Again, what's coming out of your environment, once you test it, you say, here it is. You can take flavors and move CPU and move memory and move disk to find that sweet spot in your application. And we'll touch on that when we talk about the flavors. And remember, storage performance is a capacity, not just disk space, so not just the capacity, but also for the throughput. IOPS is a capacity. Do not ignore that, or you will be very, very sorry. All right, so proper flavor definitions. You need to find the optimal flavor for your workloads. Find out what the median flavor is. 80% of our flavor is 4 CPU, 8 gig of RAM, 50 terabytes or 50 gigabytes of disk. I'm just making that up. That should be the flavor you work with as a building block. All flavors that stem from that as a baseline should be in increments of one another at about 50%. You have a medium with 4 CPUs, your large then will have 8 CPUs, and twice the disk. So it's 50% of the next highest flavor. That way, when you put these all together, they're like Matryoshka dolls or nested tables. They all fit as fractions of one another, and there's no wasted space in a compute node. You want to pack it like a UPS truck. In my Barcelona speech, we'll have a graphical representation of this and go through the numbers. Keep your corner cases out of your flavor definitions. If I need a 3 CPU with 68.5 gigs of RAM on a 27 gig volume, that is not an excuse to have a flavor for that. What you will do is you will leave huge air gaps in your capacity planning. No, don't do that. Again, use your flavor definitions to compute your bill of materials for your environment. So now you know what you need, figure out what densities you need on each one of your computes. If you have an ephemeral environment, you could probably run larger computes, say 60 instances per compute. But if you have a persistent environment and you have failure that you have to watch out for, again, lower numbers are better. But use your flavor definitions and your projected capacities to pick out the hardware you need for compute. And different workload profiles like NFV, things that are very specific that may be divergent 100% from your normal workload profiles. It's okay to have another set of flavors set up just for those different workloads. But again, follow the workload recommendations. Follow the 50%. Follow the main workload definitions. Monitoring metrics. You can't make capacity decisions without data. With the data, decide what KPIs you want. Good start is total CPU, memory, disk, as well as flavor utilization per region over time. Your region, your flavor utilizations will change. You may need to tweak those flavors. So determine basic elasticity, so how your cloud on a daily basis is doing this. These two sides, this is where the info is, to show you how your cloud is growing, because your cloud will not grow linearly. It will grow in fits and starts as people reclaim resources, use resources, reclaim resources. That percentage there will tell you how your run rate of your cloud. And here we have a small kind of calculation. Developing triggers for expansion. Again, on the last slide, we pointed out there was a 20% average elasticity, what has spiked up to 35%. Well, obviously you have to have 35% capacity to hold that spike on a daily basis. But it's up to you as operators to decide beyond that 35%, what can you carry as far financially in extra hardware over time, and how are you going to maintain that? How are you going to maintain that buffer for large spikes in and out, in and out, in and out? These should be triggered. They trigger ITSC or your ordering process, whatever it is, these alarms and triggers. Capacity management software for OpenStack. There are tools out there. The best ones are commercial right now. There is one called Cloud Kitty. It's open source. It does some price modeling. It's not there yet. Talligent gives you beautiful displays like this that tell you, what your overcommit capacities are versus your real capacities. RAM, disk. Oops, I'm missing a slide, but that's okay. So, and another one is RightScale with Cloud Analytics. Again, that's more of a pricing model. So I've given you a very fast overview of cloud capacity planning in an elastic environment. As I said, I will see you in Barcelona. I will have a full presentation on this where we will actually go through numbers and we will do scenarios and we will talk about how actually to implement these types of things. Again, thank you very much.